As you've seen, Booleans can be very useful when it comes to making decisions about a set of data. And we do have some functions that operate directly on bools. So let me run this array, and we get, it looks like 3 trues and 4 falses. These Boolean operations, they're going to operate on the true value. So what is the sum of true values? It says we have 3 true values, 1, 2, and 3. Then it asks, well, are there any true values at all? This is a more general question. And it says, yes, there are some true values. Well, let's go up here and remove the true values and run this again. So now we don't have any true values. If we run this again, it says false. We don't have any true values. If we put just one true value back in here and run this again, then the sum is going to be just one true, and this will be true because, yes, we do have at least one true value. This all method, it asks us if all of the values are true, and in this case they're not. However, if we replace these with some true values and run this again, and then ask, well, are all of the values true again, it's going to say, yes, they are all true. Sorting in NP is similar to sorting in Python. Let's create a random array of values here and sort them using just the sort method. And you'll see it goes from lowest to highest. However, this is simply a one-dimensional array. How does the sort method handle a multi-dimensional array? Let's check and see. We'll just run the sort method on a multi-dimensional array, and it sorts according to the second dimension. As we saw in our Python course, sort also works on string arrays. In this case, we have a two-dimensional. You can tell that the way we assembled this array, the first index was not alphabetically ordered, but our second index was alphabetically ordered. What happens if we change goat to lion, and we change lion to goat, and run this again? Let's reinitialize this so that these values are reversed, and then run the sort function again. You'll notice it sorts that second element as well. What happens if we put goat where cat was, and if we put cat where goat was, and run that again, and then we'll run this sort again and see what happens. You can tell again that this is sorting by the second dimension. NumPy also has some good set operations. Let's initiate another one-dimensional array, and we have multiple entries for George. We have multiple entries for Paul and for Tom. Well, if we sort this, we can easily see that we have one entry for some of these names, but we have multiple entries for other of these names. With Python, we can convert this into a set, and of course we know that set will only have unique values. So it's removed any redundancy out of that array. If we go back and we look at the original array, it has not been changed. With the np unique function, we can do the same thing. We can create a set out of this array that we created up here. And if we run set1 again, we see that the original set is still undisturbed. Let me show you that again. There where we're asking just for a set, it's a copy. But down here when we run set_1 again, the original array, the original data persists. Let's create a one-dimensional array of numerical values and run the set function on that. And it only gives us the unique values from that set. However, again, if we run set2, set_2 again, you can tell we've not changed the original. Using this in1D method, we can ask a Boolean question whether or not certain values exist in a one-dimensional array. Let's run this and see the output. It says that this first index is indeed one of these numbers, but this second index, 5, is not one of these numbers. But the last index is indeed, once again, one of these numbers. There are more set functions available in NumPy, and you can find references to them and their documentation here at this link.